Since the subject of this module is facial development, our focus will remain on the segment of embryology that pertains directly to that discussion. To that end, I won't be covering the earliest stages of embryogenesis, such as fertilization, the zygote, and the morula stage. Our story of facial development today will begin at the time that the zona pellucida is disintegrated, a phase called blastulation. This is a blastula. It's the ball of cells that results from successful fertilization. That ball of cells travels down the fallopian tube to the uterus and it plants itself into the uterine wall. The actual travel time from fertilized egg to implantation into the uterus is anywhere between 6 and 12 days. Once the blastocyst is implanted into the uterine wall, the cells differentiate and create two layers. We call this the bilaminar disc. The cells sitting on the top of this disc are called the epiblast, and those below it are called the hypoblast. I'll subtract the placenta and we'll zoom into the embryo. Here's a schematic view of the bilaminar disc, where you can see the epiblast and the hypoblast. To help orient you, the epiblast layer is adjacent to the amniotic cavity, and the hypoblast is adjacent to the primitive yolk sac. This yolk sac provides nutrition and gas exchange between the mother and the developing embryo. It's also the main organ of embryonic blood cell production via blood islands near the yolk sac. At the beginning of the third week, cells in the dorsal line of the epiblast begin to proliferate and migrate into the median plane of the embryonic disc. This begins at the caudal end as a linear opacity and is now called the primitive streak. As the streak elongates by addition of cells to its caudal end, its cranial end proliferates to form a curved ridge of cells that we call the primitive node or Henson's node. Movement of cells through the primitive streak results in formation of a groove, the primitive groove, along the midline of the primitive streak. Once the primitive streak is well established, a majority of cells passing through it spread out between the epiblast and the hypoblast to form a thin sheet of mesenchymal cells called the intraembryonic mesoderm. By the end of the third week, at the caudal end of the now trilaminar embryo, opposite the primitive streak, the ectodermal tissue thickens and flattens to become the neural plate. The neural plate is a key developmental structure that serves as the basis for the nervous system. Here's a look at the difference between the bilaminar disc and the trilaminar disc. Once the mesoderm has formed a discrete layer in the embryo and the ingress of cells through the primitive streak is completed, cells remaining in the epiblastic layer are termed as embryonic ectoderm. The earliest cells migrating through primitive node and the primitive streak give rise to both embryonic endoderm and the notochord. Some cells invade the hypoblast and displace its cells into the yolk sac wall, and the hypoblast eventually is completely replaced by a new layer of cells that become the definitive endoderm. Here's a closer look at the three layers. These cells are now responsible for differentiating and creating all the cell types needed to construct the human body. Each cell type will go on to create specific structures. The ectoderm will form the skin and nerve cells. The mesoderm will form bones and muscles, and the endoderm will form epithelium, or the tissue that covers or lines a structure, such as the pharynx, trachea, lungs, and GI tract, as well as giving rise to organs such as the liver, thyroid, and pancreas. By the end of the fourth week, cells surrounding the neural plate direct those neural plate cells to proliferate, invaginate, and pinch off from the surface to form a hollow tube. The rostral end of the neural tube develops into the brain, and the caudal region becomes the spinal cord. Also occurring at the beginning of week 4 is the folding of the trilaminar disc, creating a cylindrical embryo. At this point, we should discuss the neural crest cells. These cells play a dominant role in craniofacial development. At the end of week 4, the neural tube has been created by the folding of the embryo. cells from the lateral ends of the neural plate are joined at the crest of the tube. Researchers often refer to these cells as the fourth germ layer, or the neural crest cells. Neural crest cells migrate and differentiate into cardiac neural crest cells, vagal and sacral neural crest cells, and cranial neural crest cells. Neural crest cells make an integral contribution to craniofacial development. The facial prominences, which we'll discuss in a moment, require interaction between neural crest cells and the forebrain and facial ectoderm. The neural crest cells are a temporary group of cells that give rise to a diverse cell lineage. These include melanocytes, smooth muscle, peripheral and enteric neurons, glia, and craniofacial cartilage and bone. During the 4th week, 5 swellings appear and contribute to the formation of the face. They are the frontonasal prominence, the paired maxillary prominences, and the paired mandibular prominences. The frontonasal prominence is formed by proliferation of mesenchymal neural crest cells, and the maxillary and mandibular prominences arise from the first pharyngeal arch. For orientation purposes, we're looking at the facial or anterior or ventral view of the embryo. Here's the 5 facial prominences on the 4-week-old embryo: frontonasal, maxillary, and mandibular. Here's a more detailed look at the developing face on that same 4-week-old embryo. You can see the nasal placode, the oropharyngeal membrane, and the hyoid arch. In week 5, the ectoderm continues to develop the sensory placodes. And as we compare the changes between weeks 4 and 5, we see that the maxillary processes are enlarging and moving toward the midline. And by the end of week 5, we see the nasal pits are being formed. These are invaginations into the ectoderm. As this occurs, the tissue surrounding the pits proliferates. This forms the medial and lateral prominences. In yellow, we have the medial prominence, and the green is the lateral prominence. Here, in black, is the stomadeum, and the purple are the maxillary prominences, still in a lateral location. In blue is the mandibular prominence. At week 5, after a rapid amount of growth, the mandibular prominences are fused. And laterally in white are the lens placodes, which are the eyes. As we look and compare week 6 to week 7, we see that the lens placodes are moving from their lateral position to a more anterior location. As the maxillary prominences grow, they push the nasal prominences toward the midline, and the nasal pit continues to invaginate. As this occurs, the maxillary prominence comes into contact with the medial nasal prominence. Laterally, the nasolacrimal groove separates the lateral nasal prominence from the maxillary prominence. This nasolacrimal groove is a tube formed by ectodermal tissue that will ultimately become the nasolacrimal duct, which drains tears from the eye into the nose. By week 7, the medial nasal prominences have fused. Lateral parts of the upper lip, most of the maxilla, and the secondary palate form from the maxillary prominences. The maxillary prominences grow medially and fuse with the medial nasal prominences. The medial nasal prominences act as a facial keystone, as this is the site of fusion between itself and the bilateral maxillary prominences. Fusion between these structures forms recognizable facial features, such as the philtrum of the upper lip and the primary palate. At week 8, we can see that the frontonasal prominence forms the forehead and the dorsum and apex of the nose. The sides of the nose are derived from the lateral nasal prominences. The maxillary prominences form the upper cheek regions and the lateral parts of the upper lip. Here's a before and after that demonstrates a relatable progression from the embryo at about 5 weeks to the mature adult. And these next couple of slides are from Dr. Mark Hill from the University of New South Wales in Australia. And here we have the nearly finished product.